Hello everyone, welcome to new class. Today's class is elementary operation of a matrix. So there are 6 operations on a matrix, also called transformation of matrix. So there are total 6 operations on a matrix, out of which 3 are due to rows and also the remaining 3 due to columns. First one is the interchange of any 2 rows or 2 columns. So, the interchange of 2 rows or 2 columns are symbolically denoted by let Ri interchanged with Rj. So, the 2 rows interchange can be denoted by Ri interchanged with Rj. Similarly, in the case of columns, it is Ci interchanged with Cj. That is, for example, let A is equal to 1, 2, 1, minus 1, root 3, 1, then 5, 6, 7 is a matrix. Then we can apply R1 is interchanged with R2. So R1 is interchanged with R2 means the first row is interchanged with the second row. So we can write A is equal to, now the first row is the second one, that is minus 1 root 3 1. So first row becomes the second one, that is 1 2 1, then 5 6 7. So this is similar to in the case of columns. Next one is the multiplication of the elements of any row or column by a non-zero number. So we can represent it like this, that is Ri is changed as k into Ri. That is multiplication of elements of any row or column. Similarly, Ci is changed as k into Ci by a non-zero number. For example, let B is equal to 1, 2, minus 1 root 3 is a matrix. Now to get C2 implies, so this is denoted as C2 implies 1 by 7 C2. So what will be B? So B will be equal to, so here C2 is changed as 1 by 7 C2. So first column is itself, that is 1 minus 1, then second column is changed as 1 by 7 C2. So here we have to divide with 7. So here we will get 2 by 7 and here root 3 by 7. So in this way we are applying this rule. Then third one is the addition to the elements of any row or column corresponding elements of any other row or column multiplied by any non-zero number. That is addition of elements of any row or column corresponding elements of any other row or column multiplied by any non-zero number. So it can be denoted as let Ri implies Ri plus k into Rj. That is here addition of addition to the element of any row with the corresponding element of any other row which is multiplied by. So here one row is added with another row which is multiplied by any non-zero number. Similarly, for the column, Ci implies Ci plus k into Cj. So, for example, let C is equal to 1, 2, then 2 minus 1. Then if we want R2 implies R2 minus 2R1. So here both the addition or subtraction can be done. So if we want R2 implies R2 minus 2R1, then what will we get? So the first row is no change. So 1, 2. So here R2 is R2 minus 2R1. So R2 minus 2R1 means we have to multiply first row elements with 2. So here first element we will get 0, then second case it is minus 1 minus 2 into 2, that is 4. So here we will get minus 5. So this is the third rule. Next is invertible matrices. Let A is a square matrix of order m. Then there exists another square matrix B of the same order such that A into B is equal to B into A is equal to the identity matrix I. Then this B is called inverse matrix. Inverse matrix of A, which is denoted by A inverse. So this one we can write A into A inverse is equal to A inverse into A is equal to I. So if A is a square matrix, then there exists another square matrix B such that A into B is equal to B into A is equal to the identity matrix. In that case, that B is called the inverse matrix of A. So we can write A into A inverse equal to A inverse into A is equal to I. So in that case, this A is said to be invertible. So A is said to be invertible. And there exists a property of this inverse such that A into B inverse is equal to B inverse into A inverse. That is, if A and B both are invertible matrices of the same order, then we can write A into B the whole inverse is equal to B inverse into A inverse. Next is inverse of a matrix by elementary operations. So let X, A and B be the matrices of the same order such that X is equal to A into B. So in order to apply a sequence of elementary row operations on this matrix equation X equal to A into B, we will apply these row operations simultaneously on X and on the first matrix A of the product AB. Similarly, in order to apply a sequence of elementary column operations on this matrix equation X equal to A into B, we will apply these operations simultaneously on X and on the second matrix B of the product A into B. That is, we can conclude that if A is a matrix such that A inverse exists, Then to find A inverse using the elementary row operation. So for elementary row operation, we write A equal to I into A and apply a sequence of row operation on A equal to I into A till we get I equal to B into A. And here the matrix B will be the inverse of A. Similarly, in the case of elementary column operation, then we write A equal to A into I. So in row operation we write A equal to I into A. In column operation we write A equal to A into I and apply a sequence of operation, that is sequence of column operation on this equation till we get I is equal to A into B. So here B will be the inverse of this A. So this is inverse of a matrix by elementary operation, that is either row operation we can do or column operation we can do. And in case after applying one or more elementary row or column operations on this A equal to I into A or A equal to A into I, if we obtain all zeros in one or more rows of the matrix A on this LHS, then A inverse does not exist. That is, after doing the elementary row or column operations, if we obtain all zeros in one or more rows of the matrix on this LHS side, that is on this A, then A inverse does not exist. So let us do some problems related to this inverse of a matrix by elementary operations. So let us do a problem by using elementary operations. Find the inverse of A is equal to 1, 2, 2 minus 1. So for the elementary row operation, so let us do the elementary row operations. For that we have to write A is equal to I into A. So write the values of A and I here. So 1, 2, 2 minus 1 equal to I is 1, 0, 0, 1 into A, 1, 2, 2 minus 1. Now here we have to apply the elementary row operations. So here after applying the elementary operation, we have to get I is equal to A inverse into A. So for that, here this matrix we have to change into I matrix. So for that, so I matrix means it is 1, 0, 0, 1. So here we have to make this one 1, 0, 0, 1. So here 1 already there. Next we have to make this 2 as, that is the second row's first element 0. So make this element 0. So for that we have to change this row, that is R2 implies. So how will you get this element as 0? So for that we have to do R2 implies R2 minus 2 times R1. So while doing this operation here, we have to apply that here also, that is in the identity matrix also we have to apply this row operation. So what will we get? That is first element is 1, 2, then here we will get 0, then R2 minus 2R1. So here minus 1 minus 2 into 2, that is 4. So here we will get minus 5 equal to, here this is 1 0, then this 0 will be 0 minus 2 times this one, so minus 2. Then here also 1 minus 2 times this one, that is 1 itself, and this a is here itself. Next we have to make this element as 1. So how will you make this element as 1? So to make this element as 1, R2 implies it is minus 5 here. So we have to multiply with the minus 1 by 5. That is minus 1 by 5 R2. So R2 implies minus 1 by 5 R2. That is minus 1 by 5 into minus 5. So we will get it as 1. So next step is this one. So we will get it as 1, 2, then 0, 1 here. That is equal to, and here we will get 1, 0. This is minus 2. So minus 2 into minus 1 by 5. That is 2 by 5. And here we will get 1 into this minus 1 by 5. That is minus 1 by 5 into A. Next we have to make this element 0. So for that we can do the operation, that is R1 implies R1 minus 2 R2, that is multiply this element with 2, then subtract. So here we will get 1, 0, then 0, 1, and that is equal to, then what will be here? So here 1 minus 2 into this one, that is 1 minus 2 into 2 by 5, that is 4 by 5. So we will get it as 1 by 5. Then here we will get 0 minus 1 by 5 into 2, that is 0 minus minus of minus plus 2 by 5. So here we will get 2 by 5, then 2 by 5 and minus 1 by 5. So 2 by 5 minus 1 by 5 into A. So here LHS we have got I. So I equal to A inverse into A form we have obtained. So which is A inverse? So this one will be the inverse of this matrix A. So A inverse is equal to 1 by 5, 2 by 5, then 2 by 5, then minus 1 by 5. So in this way we can do the elementary row operations to get the inverse of a matrix. That is, first of all make the first element 1, then make the second row element 0. So this is in the case of 2 by 2 matrix. In the case of a 3 by 3 matrix, that is in the case of a 3 by 3 matrix, there will be 9 elements. So in this case, first of all make this one as 1. Then we have to make this element 0 and also this element 0. Then in the second step, we have to make this element as 1 and make this and these elements 0. Then the next step, this element we have to make 1 and these elements 0. That is, here we will get 1, then we can easily make these elements 0 by subtracting like this. That is, for making this element 0, R2 minus whichever is the element here, then multiply with the 1, then subtract. So in the similar way, we can do the same operations here also. That is, here first of all make 1 here, then make these elements 0. So this is the case of row operations. Then in the column operation, that is elementary column operation. So here we have to write A is equal to A into I, and then make this one as I is equal to A into A inverse. So here we have to write A is equal to A into I and make this A as the identity matrix. Then here this identity matrix will become the inverse of this matrix A. So write A is equal to this one, that is A is 1, 2, then 2 minus 1 equal to A into 1, 0, 0, 1. So here we have to do the elementary column operation. So here first step is to make this column element 1 and then make second column element 0, that is this one as 0. So in row operation we do like this. So here this is column operation. So first of all make the first element 1, then the second column element 0. So for that, here this is 1 itself. So next we have to make this one 0. That is C2 implies, so here C2 minus 2C1 we have to do. So that is 1, next is 0. Then here 2 itself, that is C1 no change. Then C2 is change. So here C2 minus 2C1, that is minus 1 minus 2 into C1, that is 2 into C1 is 4, that is minus 5 is equal to A into first column is 1, 0. Next column is 0 minus 2 into C1, that is minus 2. Then here 1 minus 0, that is 1. So this is the first step. Then next step is make this one, that is the second column, second element we have to make 1. So here this minus 5 we have to make 1. So for that C2 implies minus 1 by 5 into C2 we have to do, that is here we will get 1, 2. So C2 is changed, so 0 then 1 equal to A into, here we will get 1, 0. So here we will get minus 2 into minus 1 by 5, that is 2 by 5. Then here 1 into minus 1 by 5, that is minus 1 by 5. So this is the second step. So in the next step we have to make this one 0. So to make this one 0, we can use the second column element 1. So C1 implies C1 minus 2 C2. So C1 implies C1 minus 2 C2. So while doing operations in this case, here this is 0. So no change will be here. So here we will get, so 1, this one will be 0, then 0, 1 equal to, then here this is A into, so first column this 1 minus 2 into C2. So 1 minus 4 by 5 is 1 by 5. Then next 2 by 5 here. Then next is 0 minus 2 into C2. So 0 minus 2 into, that is plus 2 by 5. So here we will get 2 by 5, and here minus 5 minus 1 by 5 is there. So here we get this as the identity matrix. So this one will be A inverse. So this is in the form I equal to A into A inverse. So A inverse is equal to 1 by 5, 2 by 5, then 2 by 5 minus 1 by 5. So this is A inverse. So in this way we can do the elementary column operations. So for the elementary column operation, first make the first column element 1, then column wise elements, that is the second column first element, then third column first element we have to make 0. Then in the next case we have to make the second column second element, that is second column second element as 1, then make the corresponding elements 0, that is in the case of a 3 by 3 matrix. So in the case of a 3 by 3 matrix, first of all make this one 1, then make these two as 0, then next this as 1, then these two elements 0, then next make this one 1, then these two elements 0. So in this way we can do the elementary column operations. So in any method we can do the elementary operations. So elementary row operation is much easier than this elementary column operation, because here there will be some doubt in the case of column operation. So always do the elementary row operations to find the inverse of A. Any method you can use, much easier is elementary row operation. So in the next class, let us discuss more problems related to this elementary row operations to find the inverse of a matrix. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.